Stroke in particular, one of the outcomes, depending on how it affects the pathway. So you can often tell where a stroke may be if there's been some visual field loss. So you get a darkening of where you just can't see anymore in part of your visual field. And different areas of the visual pathway from the back of the eye through to the back of the brain are susceptible to different parts of your visual field being affected by that. And so because there's a bleed, it actually damages the nerves and you get ischemia. So you get the sort of nerve loss. So that's one of the things that can happen is you actually just lose part of your ability to see in your visual field. And so we use a thing called a visual field test to detect those things. You can get, depending on the areas of the brain, you might have issues with connecting with recognizing things. So your vision may be okay, but you can't find the label of things. I remember a lady who was in her 80s and she had a stroke and she says, I can see the letters, but I can't tell you the names. So I said, well, how about you draw them in the air for me? And then so she started drawing the shapes of the letters in the air, and then she was able to say them. So she'd lost the ability to directly see and say, but she could say them if she brought some motor system in. So you get these very interesting losses of function. And I don't mean to, it's not a cold-hearted fascination. It shows how much the brain is a fascinating thing, but it can be obviously quite debilitating for people. Part of our strategies that we're looking at, if someone's light sensitive, are we using tints to try and help them? If someone's had double vision that's resulted from concussion, stroke, brain injury, how do we solve the double vision? Are we able to get the two eyes working together again through vision training? Do we need to use some partial occlusion to try and block some of the double vision? And so that's the kind of things that that's what we're considering when we're seeing someone is, okay, what's the nature of the injury to your visual system? But more importantly, what is it that we might be able to do to get your quality of life improved, either through, removing interference caused by the injury or trying to rehabilitate function again.
Can emotional stress also interfere with vision? Because, like, I don't know if you ever saw that HBO series, Band of Brothers, which is based on like actual events, actual people. But there's a character in there, like one of the soldiers who was in France after D-Day, and because of like the stresses of battle, he experienced hysterical blindness. Like he just out of the blue, his vision just stopped, and then a little bit later just came back again for no reason. So it seems like that's an extreme example, but I have heard that stress can also interfere with our visual abilities.
Yeah, look, there are some of them. There's a bit of conjecture about some of the syndromes out there. There was one that was called, let's see, some of the names. There was one called stress syndrome. There was another one called bilateral hysterical amblyopia, where you get a loss of ability to see central vision clearly without any signs of pathology or refractive error. So no short-sightedness, no astigmatism, long-sightedness. And the literature seems to indicate that it's linked with some sort of period of stress. There is a saying in other fields, and I don't know if this is still a medical thing, but they call it conversion, where your brain kind of wants to shut something down. So this is purely anecdotal. You hear stories of a child who had an injury to an arm years ago and then has a period of high stress, and then that becomes paralyzed because the brain goes, I'm stressed, I need to shut something down.
Yeah.
Okay, what area was weak? So let's shut that down. And there's some conjecture about whether that's part of what we see visually as well.
Mm. Yeah, I mean, this is why I'm a lot less concerned about AI than many people, because I think that we don't really understand how our own brains work yet. So
Yes,
it's a leap to think that we can create a machine that exactly mimics what the human brain does.
I have to say though, it's that certainly the parts of visual neuroscience owe a lot to the AI and robotics kind of industry, because a lot of what we understand about the human visual system comes from the computer industry trying to work out how to make, a bit like reinvent the octopus eye. How do we make these things work? And so it comes from trying to solve problems. And effectively, that's the way the visual system has developed. I mean, everything that we do, and we even look at dysfunctions in this practice, is that some dysfunctions, if they're a change in visual behavior, so people develop eye teaming and focusing problems as a result of what they're doing with their eyes, their habits, we sometimes like to ask the question, what problem are you trying to solve by using your eyes that way? What kind of stresses are you dealing with? And so, it's thought that that's the way our visual systems have evolved. And like I was saying, AI and computer, they're trying to solve problems. They're trying to get these robots and computer systems to do things with visual information. And so we learn a lot through their, convergent thinking about things.